All right, guys, want to thank you for your flexibility and give you a little bit of tips on what areas to focus on the reading. I'm sure you guys all read through the chapter already very thoroughly and understand everything. I'm going to give you a little bit of a sneak peek at the teacher's edition, so don't tell anybody. But there's a couple things I want us to be on the same page in regard to before we start diving into solving some of the circuits. And I'm going to look at a couple things in the book, like some of the rules, and we're going to talk about what to remember when we're solving some of them. So first off, for starters, we're going to be talking about voltage drops. And when we talk about voltage drops in regard to series circuits, we're pretty much just talking about how much voltage is applied to that resistor. So whatever part of that circuit's at, the voltage drop across each of those is going to be individual. So that term voltage drop is pretty much just saying the potential difference from one side of the resistor to the other. All right. Now, I got a couple other things. Series circuits, it talks that they only have a single path for current flow. Should be pretty obvious to everybody, and they got a couple diagrams in here. But I want to get down to the rules where we talk about things to remember when we get into those. So there's two of them that are going to come in real handy, and we're going to be using them pretty much in almost every single one we do. So right here, pay special attention to this area. In a series circuit, the sum of the voltage drops across all the resistors must equal the voltage applied to the circuit. So we're going to be using that rule to make a lot of assumptions about our circuits and fill in missing values. So if we find enough of the values, we can find the total. If we have the total, we can use subtraction to find out one of the missing ones. So we'll get into that a little bit too. All right, and when we come to the next page, we got a couple rules here too. So these three rules you're going to need to memorize. We're going to give you your formula cheat sheet, but you're not going to be using that on the test. You guys should be good enough with Ohm's law where you know most of those by now. And then these will be so second nature. By the time we've done all the practice problems, you guys should be good to go. But remember this and embed it in your mind. So we got the three rules here that apply to series circuits specifically. The current stays the same at any point in the circuit. So that means any of the resistors are all going to have the same current. If you know the current for one of them, you know it for all of them. Only in series circuits. The total resistance is the sum of all the individual resistors. So if you know all the resistors, you can add them up and get the total. The applied voltage is equal to the sum of the voltage drops across all resistors. Exact same concepts. If you know the voltage drop across all the resistors, you can easily add those up and find the total. All right. So the rest of the book is just going to be pretty much them doing sample problems. This part's just talking about pretty much one of the rules that we already discussed there. But those are the most important parts. I won't want to move on to solving any of these until we have embedded in your mind. So you can look at your formulas on the formula sheet, and they kind of say the same thing, but just remember these rules. So when we get into solving series circuits, if you got this down here, then it'll make sense when I'm kind of guiding us through solving a lot of those. All right, and again, if you guys got any questions, go ahead and email it. We'll try and respond to the whole class when we get those so that everybody's not asking the same things. And we'll try to be available to help you guys out in any other way we can. All right, I'll check in with you guys again soon.